briefly about exhaust components. This is exhaust componentry, and we're only going to talk about what they are. We're not going to talk about their effects, what they might do. These are things for next time, because we need you guys to tune in for next time, and I'm sure everybody here wants to go home at some point. The header is a construct of multiple parts, and that's going to be loud. That's all right. The long tube versus tuned length, we're going to talk about the primary, which is another definition of a part, and we're also going to talk about a slip fit collector, because one of our competitors have called us out.
No, all of them.
That, yeah, fair enough, fair enough. That somehow believes a slip fit collector leaks, and therefore is inferior to a welded collector.
They're not wrong. Their slip fit collectors do leak.
Their slip fit collectors do leak. They can't do it appropriately, and we'll call them out on it. That's fine.
We'll send them a thank you note for that, too.
You're welcome. I appreciate that. If you look at any motorsports collector that is worthwhile, you will understand this is the collector. This part, it collects 3 different exhaust flows and it combines them, hence collector.
Header also.
Header
is a term derived sometime, long time ago. I don't know exactly where. I just got books where it started popping up.
Mm-hmm.
The correct term, like intake manifold. Correct term is
exhaust manifold.
Now,
right.
Single cylinder engines don't really have the manifold is term for collector.
Sure.
On it, so it's just intake manifold collects everything.
Yep.
Exhaust manifold goes out. Your HVAC system in your house has an intake manifold.
Yep.
And it actually has an exhaust manifold. They
call
it that.
Yep.
And it's just all it means is basically collection, not collections like you owe your money in your credit.
Yeah.
But
like it combines all of the things together.
This takes all of the exhaust gases, collects them together. Everything's different. Diesel, turbo, exhaust manifold on a turbo engine, turbo manifold. It's still an exhaust manifold, collects it all together, and then it just has a turbo bolted to it. So we could take this header here, one side, and we could, if we really wanted to, we could cast this and call it an exhaust manifold.
Yeah.
But it's still an exhaust manifold. So terminology-wise, for everyone, we're just talking about the outlet side of the engine in this case. So it's not that it's...
all the combusted gases are trying to leave and go out into the universe.
Guiding them this way, essentially.
Yep. So this section of the exhaust is called a primary, the primary length. And the primary length is important because it is the direct connection between the cylinder and the collector. And I'm going to do my best to not go there. This is important for later, so just bank that. This distance is important. You're welcome, Kevin. We had a question from a friend of ours. How do you calculate the amount of time for the pressure wave that leaves the cylinder for it to get to the collector and come back to the head? How do you calculate that? And our answer was math. That's how you calculate it. And that's all we're going to share.
Yeah.
Math, bro. If you don't know the math, I'm not going to share it with you.
Anyone interested in an exercise, which generally when I say this stuff, because I've had to learn all this at some point myself, when you have a question like this, just what I tell everybody, get a sheet of paper, write a couple of questions down, or just put a couple of variables in. When you have a formula and you don't know what's there, you have to fill out the blanks. Well, usually everyone says, "Oh, well, what do I need to write down on here? What do I need to ask for?" What characteristics of the engine that you know about would possibly define this, and start writing them down. Doesn't mean that's it and that's how it's used, because a few variables, input variables, are not easily defined or attained.
Yep.
Which makes it quite difficult. Which is how you get to a rule of thumb. Which there's a couple numbers I could put out there. Which that's the number.
And they're wrong.
They're
some
correct
cases.
For one aspect. They're correct.
For Chrysler, they were correct, and for everybody else, they were wrong. For those of you in the know, Chrysler understood resonance charging on the intake side a long time ago, and what they purported in their patents and what they purported in their papers was correct for one engine. It was not correct for all engines. And because of that, it's kind of right. They didn't explain the math. They just put a really shortcut formula. And when that shortcut formula is used for things other than the engine they were talking about, it's wrong.
It would be, if I said this is the header length that makes power on every engine.
Every engine forever.
And you just run this and everything makes, well, no, this only applies to
the specific engine that it's designed for.
Correct. So
we're going to talk briefly about long tube versus tube length. Long tube is a shortcut for tuned length.
And the biggest reason where I believe this came around for anyone are older than us, I would say.
Yeah. Shorties,
go to car that this was big in, that I think this kind of started around in, was Fox body Mustangs.
Yeah.
Where they had exhaust manifold on it, log exhaust manifold, meaning it's just cast, collects everything and dumps down here.
Right.
And somebody wanted to build a header, so they made a collector, and then they wrapped a couple tubes. Well, the back tube was about 2 to 3 inches long, and then the front one's a foot long.
Right.
But they were just little...
Not an equal length
They were
header.
just shorty little headers. They replaced the stock exhaust manifold.
Right.
Were they better? In some way, sure, but we're talking about a 200 horsepower, 5-liter motor.
Right.
So, not efficient.
Not really very efficient.
So if somebody said, hey, that doesn't make more power, they took that off the car, took the cat secondary stuff off, and somebody built, and I'm not saying this is where it originated, this is just a really popular Mustang Camaro stuff. You know?
Yeah.
And they built a header best they could, and then now they're running with long tube.
Yeah, 3
it's
foot
a
long,
tube header.
whatever they are.
So that terminology has kind of stuck for a
Right.
long time as a rule of thumb. Oh, put long tubes on, you make more power.
Yep.
Shorties are cheap and easy. And it should have died. I think it should have died out in the last 10 or 20 years.
Right, but it's just kind of continued.
Summit Racing still sells shorties and long tubes, so guys that buy those cars, look up online. They want to get that car, or they get any Mustang or Camaro, and you look at those parts, and they still have shorties and long tube headers listed, because that's what's been around for 50 to 60 years.
Right.
So if somebody changes it in that market, somebody's like, oh, well, they have tuned length headers. Well, what are they tuned for?
Right. And what we're talking about with tuned length is the RPM for peak power.
This length, well, not from here.
Yeah.
From exhaust valve.
Yep.
Down here. This length is specific, and I'm not going to go into too much detail.
We're sharing some secret sauce.
Well, no, I'm going to censor myself on some of this.
Yep.
This length is specific.
Yes.
And at some point, or I'm not going to say the next words, that is correct for its goal on why it was designed to make
power
at this point. And I'm not going to dig into.
We'll talk about it. That's a 201 thing, and I'm okay with sharing a bit of this because Porsche designs them a certain way, and we design them a slightly different way. Both are important and appropriate with their boundary conditions. So Porsche is looking at generating power a certain way and generating emissions.
Because you have
go ahead.
Number one,
Yep.
exhaust test path emissions. Well, you can't have the cat way out here.
Right.
On a stock car, you need to have it close to the engine because the most heat coming out of the exhaust ports.
Yep.
So you need to heat this cat up.
Which, from a chemical standpoint, when you're trying to react components together, reactions happen faster at higher temperature. The temperature is emanating from the cylinder. The highest temperature is when the piston is being pushed down before the expansion happens. As the expansion happens, the temperature decreases. The closer you can get this catalyst to that event, the more efficient that catalyst is going to be.
And number-wise, you have to get the cat, when you first start an engine, above 600 degrees Fahrenheit.
Yep. Or it doesn't work
or
at all.
else it doesn't work at all. Well, and you have to do older engines. The OBD2's been around for closing in on 30 years now.
Yeah.
And that's when they really first started monitoring this to heat the cat up quick enough. Well, some of those engines were 2, 3, 4, 5 minutes to get it hot.
Yeah.
Nowadays, I think this is 30 seconds.
Sometimes less.
To get it up to temperature.
Yep.
But you can't have it so many feet away. You have all the extra distance from the head or the combustion chamber where the burn's happening all the way out there to the cat is you have thermal transfer hot to cold because ambient temp and we're dealing relative, not absolute temperatures, which matters. It's 60 degrees in here, and then the exhaust gas is 1,000, 1,200, 1,500 degrees. Well, it's going to radiate the rate of heat transfer to the atmosphere, so you're going to lose all this heat. So you have to keep shoving the cat closer, closer, closer. Well, eventually
you can't get
it's
it
too
any
close,
closer.
but now we're losing the aspect of exhaust manifold design to allow the engine to make the maximum performance. So we have to compromise somehow, and we have to put the cat in a certain spot.
Yep.
So even the material of the catalytic converter matters in this case, but you can't just put the cat here. Okay, we're going to move it a couple inches. Mathematically, empirically, the cat's placed in the factory exhaust manifold.
Hey, there you go.
Hey.
We got one. How about that? We have one here.
We have one right here. It is placed as close as possible, and this is why they're built this way. When someone says, "Hey, why'd the factory do that?" Like, what's the intent? Why they should have just
for performance.
They should have done it this other way in the first point. Well, emissions, you got to get the cat warm up. Got to pass emissions first. They designed the rest of this to make the amount of power they can. Now they don't have this is a GT4 RS exhaust manifold. This is a driver's side, and this whole design, runner, the tube where they merge together here. This would be the manifold where they merge, or collector, as everyone says before the cat. This whole design and this whole shape here has been designed on purpose this way, and of course they are trying to get. They're not trying to get. They know how to get the amount of power out of the car their goal they're shooting for, and they've had to redesign this. So if you go from a 991 GT3, 997 GT3 to 991 to 991.2 to a 992 GT3 to a Speedster, 718 GT4, all of these, they've evolved to the extent where they need to continue to improve the horsepower goal while meeting ever more stringent emission standards. And then this part also has to last on a racetrack.
Correct.
So
which is a difficult problem to resolve.
So how to take this part, which is a well-designed part, and improve upon it to not free up horsepower, but create more horsepower.
Correct.
Two different terms. The whole, we're not going to get to it this time.
Nope.
The back pressure.
That's next time. But back pressure.
Yeah. Oh, I love that one.
That's another 4-letter word. That's a lot more than 4 letters. You can tell where long tube came from, and if those of you who are going to look at the overall length of these and compare them, might actually be double. But that is a comment for a different day. So, secondary is the amount of length between the collector outlet and
the next merge point.
The next merge point, which is generally the atmosphere. It doesn't always have to be, but in a 911, generally is close to.
It's the center muffler.
Or the center muffler. And
tertiary on these cars would be
atmosphere,
which is third.
Yeah. The catalyst we talked about. For those of you who are environmentally conscious and concerned, Charles raised an interesting point about thermal efficiency and mixing. So our catalysts are advanced, and they are not based off a cell nomenclature. A cell nomenclature is if you grab a box of straws. This isn't a box of straws. This is waved plates that are put next to each other so that the gases can mix much more quickly and much faster. Much more quickly and much faster. How about that? Quickly and faster are the same thing. So the point of these cats and the reason that we're able to use them is we can put them farther away and we can still get the same conversion as a cat that's much closer. Hey, there you go.
Here we go.
There's a cell cat. So
this is the more designed for.
That's circa 1985.
Yeah, this is essentially a wafer sheet, and they roll it together, which is spiral here.
Yep, spiral wound. The
And this is good. This works great. Porsche's used these forever.
Yep.
993 turbo.
Yep.
If you ever want to steal cats, that's
30 years ago.
You'll probably make 10 grand off stealing those.
Yep.
HJS,
Yep.
Motorsport, excellent cat company based out of Germany.
Yep.
They still do them this way, which works. And you can't. This one's a 300 cell.
Yep.
I think. And they're basically, if you took a 1-inch and you cut a chunk out of it,
that's how
you would
many
have
cells
300 cells in it. Or the other way to math it, if this was square, it would have 10 cells and then 10 cells and then 10 cells if it was 100.
Yeah.
So if there's 200's popular, 100 usually is what Porsche Motorsports uses. So in a actually
and the Abramovich uses
cup car, so 991 cup car, 997, all the factory race cars run this style wound metal, thick wafer, HGS Motorsport, whichever, 100 cell. So at idle, they're not doing anything. In those cars, common misconception, any car imported into the United States to be sold here new has to pass emission standard for what it's intended for. So a race car still has cats on it.
Still has to pass emissions.
We have them here, we have factory, whichever. Now they don't have a OEM style. They have a metal wound, but they're 100 cells. So you can literally see through them. This one's tougher.
Yep.
But the others you can see through them.
Like this one, you cannot see through.
And these are made. Do we? I don't think we have any. We'll have to dig it out later. The wafer style.
So this is the chemical engineer in me is very impressed with this because I remember my senior project was making a better catalyst, and that's a huge business. That's $1 billion, and none of us did this. None of us did this. We all used the existing constraints and we used the chemistry of it, the density of the platinum, palladium, the localized density, the turbulence associated with it. These guys have a pretty trick solution to that where they've substituted wound foil to make it with stacked cards that are
a herringbone shape.
Yeah, a herringbone shape.
So the gases have to do this as they go through it.
That's right. And the gases are also allowed to come in at very low flow rates and expand through all of these cards through their entire width. Versus in this design, the gases would come through and be constrained in this area. If that's all the area that they could be pushed through, and that's all that they're going to be exposed to when they come out on the other side, like a box of straws. So the reason why Dundon exhausts do not need a tune is because as far as the gases are concerned, they're being converted in the same ways, and in some cases better than the catalysts that come on the car originally. This is a cheaper way to make them. You can take them and you can just imprint a roll of foil endlessly, wrap them up, put them in a core, ship it off, done. This is a more expensive way to make them. There's some elegance and technology required to get these wafers to stack next to each other and be wrapped and stay that way. And when we first started using these, they weren't perfect. We had to help the manufacturer with this particular application to improve them. And that's why we lifetime warranty our products, so that as we're innovating, as we're developing, our customers don't get squeezed by it. We make it better over time, little by little, and both our suppliers win and our customers win. So I think we're going to stop here. We're going to get to the rest of the things that y'all might be more interested in. Although we covered a lot of topics in this that I think are going to be interesting. We'll do a 201 after we do some suspension and some other things, and we'll come back to 201, let you guys digest this for a minute. I'm excited for y'all to hear it, and I appreciate everybody sticking around to assist. Any parting words?
Just, all I got to say is if anyone's questions or comments, whichever.
Yeah,
I mean,
shoot us comments.
There's a lot of our products we don't really share. We need to. I'm always willing to learn. I always learn something every day. If you don't learn something every day,
if you're not curious, you're dead.
Yeah,
you got to stay curious. So, all right, y'all. Thank you for your time. We're gonna get back at you next time, and I can't wait until we can tell you more. Good night.